one of the piece technologies we had when we automatically generated the magic that was our website was Hibernate, or more accurately, realistically, JPA, Java Persistence Architecture. So the value of Hibernate is taking JDBC, which is a very basic tool and does connect to the database very nicely, and aligning it more simply and elegantly with the data in our Java application. Within JDBC, we spent a lot of time formatting queries and grabbing objects and doing getters and setters and get string, set value, get integer, set value. A lot of repetitive tasks inside of there, and then adding validation rules and all that sort of stuff that goes on top of that. It's not hard, it's just not super value added. You're not using a lot of brain power to make those things happen. But if we look at the two formats, fundamentally, we have this description of data in a database, student ID, first name, last name, degree, program, gender. We have this description of data in an object, ID, first name, last name, degree, program, gender. They're not exactly perfectly named the same, but they have a very similar format. They mean the same thing. They model the same thing. They have the same data that's going back and forth. So what if there's a way where if I know the code that I would normally generate, and I know all the columns I'm going to get data from, I know all the setters I'm going to put data in, instead of having to write this code, copy and paste, fix it, whatever I have to do each and every time, it's not hard code. It's mundane code to do. What is the way I can just generate this code? Just say, hey, spit this out for me. Write a little tool to spit this out for me. Well, that's exactly what somebody came up with a while ago. They said, let's create this thing called object relational mapping. We have a relational database out there. We have objects over here. They're good data in each format. They're just in the wrong package. One's Christmas wrapping. The other one is for birthday. I don't want them to get the wrong packaging. So it's the same present. Let's just put it together in a way that means the same thing internally. So the concept of object relation mapping is I can go between objects into tables, from tables into objects by just looking at the attributes as long as I know what columns the attributes represent and vice versa. And then I can take other bits of information, such as the fact that there's object trees on one side and there's foreign keys on the other side, and I can even start to put object relationships and table relationships together and even represent networks of objects, trees of objects, and load those up the same way. So since I have tables on one side, I have metadata associated with those tables on that side. Basically the definition of the rows, the columns, and then each row represents one entry of data. A class represents the version of the data on the Java side, and each attribute represents a new item of data, and each object I create from the class is a new instance of data. So a row is equal to an object. A class is equal to a table. So if I use that concept and I take, hey, these are my columns, these are my attributes, I point them at each other, boom, I have all the information I need, but how do I do that? How do I grab good Java data from this messy JDBC table structure without doing any coding? Again, that's where JPA comes in, the Java Persistence Architecture. Hibernate is one of the instances of them. It's not even actually the one we're working with, but it's the most commonly heard one, so that's why the title of it is Hibernate up there. And so the way it happens is one of two ways. One of the ways in Hibernate to do that is through an XML mapping, where we say for the student ID inside of there, this is going to be the ID for the table, and it ties to this column name called student ID here. First name ties to first name, last name ties to last name. We just tied together in this XML document that lives outside of our Java code, but with our Java code, it gets loaded when we start it up. So it's pretty straightforward. I can create a very simple little Hibernate program that has this configuration. It configures it based off of that file we saw. It knows the file is out there. It knows what the name of the file is. It loads it in. I can actually add configuration as well. We're going to see this as well to this course class that goes along here. And then I get some plumbing from Hibernate. A session factory is kind of the way I deal with connections out there. A session is the way I deal with kind of like a statement where I can do some work. And then a criteria is a search on all objects of a student class. So this will return to me all students in the database. On the criteria, instead of having to do SQL, I can actually add in, give me students whose gender is male. Give me students whose GPA is above 3.0. There's all sorts of criteria I can add to this to be able to do a query instead of having to do all of the SQL stuff. That's another big popular reason to use some of these frameworks is if you don't know SQL real well, it'll simplify it so you don't have to know SQL real well. Now, that's the old-fashioned way to do it. Java 5 gave us this notion of annotations. You might have seen the list of annotations when we went and looked at it in the sample. If you watched that last video out there looking through the code, you would have seen these at symbols. And so at entity is saying, hey, this is an entity class, which we saw. We needed to create the entity class before we could generate the code to build our website. And then it points to the table named courses. So the course class is stored in a table named courses. And so then we have an ID, which is the column course ID. We have a column course name that maps to this variable name. Notice they don't have to match anymore. The course name database column is just the name of the course object's name. Course category, again, course category. Just show you that they don't have to line up. They might line up, but you have to specify which attribute from the table maps to which column in the database. And so from there, I don't have to write any SQL. It does the insert, it does the update, it does delete, it does query by one of them for me. I don't have to write SQL code anymore. So I go through, we get a transaction, I create a student object, set the first name, last name, degree, program, gender, all that stuff, and then I do a save or update. Because it knows how, based off of those, to say insert into table where values, first name is this, last name is that. It knows how to do all that for us. So this is a tiny, tiny taste. I mean, we're spending 5-10 minutes talking about what Hibernate is. We could spend a whole day of classes talking about all the things that Hibernate can do. If you're really curious about the structure of this, go back and look at the code that was generated. It'll show you a little bit more about what it works. But honestly, it doesn't get much more complicated than this as far as mapping goes. You will see mostly these annotations out there. All of your classes that you generated, the product class, the customer class, will have these annotations, and they're creating the classes based off the database structure. It'll actually have additional columns out there, additional annotations out there describing the data as it's defined in the database. Those are optional, but it does help you add validation rules, and those validation rules gets translated up into the website as well. It's not a Java thing that does that. It's a NetBeans thing that's doing that, but it's kind of a cool NetBeans thing. So it allows us to basically decorate and tie our two different technologies closer together and keep the rules consistent across them. So it's a cool little tool that you're free to go investigate further. That's all we're going to talk about it for now because we've already generated the code. There's nothing else we need to do as far as the assignment, but at least it's in your toolbox now.